Hi everybody, welcome back to Chem 140. So a student asked to go over how to write the Lewis structure for CO, and CO is a very weird one. It sort of breaks many of the rules. So that's a good little segue before we start naming stuff. But before I do that, I do want to talk about the agenda items. So down below, you can see the lab worksheet number 3 is due on Wednesday. That's tomorrow. Make sure you get that in before the deadline. Closing date is Thursday. You get 24 hours past the due date. And then quiz number 5, which is units 9 and 10, is due next week on Monday. And do note that there will be a quiz for unit 11, which will be due next week on Tuesday. So there will be 2 quizzes due next week, kind of as a result of us not finishing unit 10 last week. The quizzes kind of compact a little bit on the timeline. So just be mindful of that. Make sure that you aren't waiting until the last minute to do them, because then you won't have any time to study for the naming quiz, which is admittedly the more difficult one. So we're going to draw the Lewis structure of... Oh, I got to go over here first. Let me just clear that out of the way. We're going to draw the Lewis structure of CO real quick. Now, we're going to do it using the 5-step plan. So remember that the first step is to count valence electrons. And so for CO, if carbon's in group 4 or 14, it has 4 valence electrons, and oxygen being in group 16 has 6 valence electrons. So you don't have really much to work with here, do you? And then step 2 would be the framework. So we're just going to connect them together. C is the central atom, but there's only 2 atoms, right? So we'll just do that. My bond costs 2. And then I'm going to put electrons on the outer octets first. So that would be 2, 4, 6. And then we would do inner octets, or central atoms. So I would do something like this. And then I would check to make sure everything has an octet. Well, carbon surely doesn't. It only has 4 electrons. It's got these 2, and then the bond. So the last step is to make multiple bonds. And so we would do that, but we can't get rid of these and put them in the double bond, because that doesn't help carbon in any way. It already has too few electrons. I can't give those away to share. So I'm going to share these over here. So I'm going to share 2 pairs, so everything has an octet. And then this is the structure. Now you're probably looking at that and going, well, that doesn't look right at all. Didn't we say something like carbon wants to make 4 bonds and oxygen wants to make 2? Well, this is 3 and 3. And this is one of those yes, but moments in chemistry that I'm not very fond of, because exceptions do exist for all sorts of molecules, and that those guidelines that I gave you, where 8 minus the ones digit of the group number is how many bonds it makes, those are typical guidelines, but not universally true. And in this case, you could see that it doesn't work. What you're going to want to try to do is prioritize the octet rule, and then the other guidelines that I give you. So following this framework will give you the accepted Lewis structure. So always make sure that you are following this guideline. And then exceptions fall where they may. Like in this case, oh, I made too many bonds with oxygen than I would expect. Well, it's an exception then. Use those guidelines if you have a choice of what to do. So like if you had CO2, this would be the structure that you would get, as opposed to maybe this structure, which technically everything has an octet, but this is the better structure because we prioritize oxygen having 2 bonds instead of 1 or 3. And so if the option exists, then take it. But in this case up here with CO, the option doesn't exist. This is the only way we could satisfy the octet rule. Now, if that sounds a little bit hand-wavy and like, I don't like that, doesn't feel very certain, we're going to talk about a better way to do this in 161 when we talk about formal charge. We don't cover formal charge in 140. It's just not in your text, so I don't want to introduce new things. But for now, really what you want to do is, again, follow the 5-step plan. This will get you 99% of the way there. And then if you have a choice where it's like, oh, I have 2 options, then follow the trends that we were talking about, such as 8 minus the 1's digit of the group number, and so on. Okay, I hope that helped. Let me know. Alright, so today we're going to actually name things formally. So there's going to be a lot of typing in the chat, at least to the best of your ability. I realize some formulas you can't really type in. We're probably going to do the first hour of mostly ionic compounds because there's quite a few examples just to get you into the practice of it. Molecular compounds are much easier to name, but the trick is that they follow a similar set of rules that are not exactly the same. So your job today is to recognize differences in the rules and apply the correct rules. So remember, it's an online class, right? You can check your notes whenever you need to. So make sure you clearly label, like, this is for ionic compounds, this is for molecular. Like, use separate pages or something like that, just to organize it, because a lot of students mix up all the rules, and then they get lost and are like, oh, why did I get it wrong? We used the wrong rules. Okay? All right, let's get started. We're going to start with what feels like it should be really obvious. Like, if that's our scheme for naming, why are we spending an entire lecture on this? Name the metal, name the non-metal with I. That feels real straightforward. You've probably already heard me saying things like sodium chloride already, as opposed to sodium chlorine. And that's where these rules come in. We've been doing this sort of all along, but there's a lot of nuances that we've brushed over. And we're going to go over all of those nuances today so that you know what goes into a name. We're going to start by naming the metal. The metal is fairly straightforward. It's whatever it says on the periodic table. So if I gave you Na, you would just write the word sodium. If I gave you CS, you would write the word cesium. If I gave you Al, you'd write aluminum. And that's easy enough. Now, the name by itself is all that's required if your element is in group 1, 2, or the element you're looking at is aluminum. So, oops, sorry, I'm diagonal on my thing. Let me try that again. So again, group 1, 2, or aluminum. You just write the name by itself. Pretty straightforward. Now, there are a lot of metals that are not in groups 1A or 2A, or are not aluminum. You have to do something special with those names, and that is you have to indicate its charge as part of its name. Now, why do you not have to do that with these elements? Group 1A, Group 2A, or aluminum? That's because when I make an ion out of sodium, there's only one ion that can possibly form, because elements in Group A follow the octet rule, right? So here's my sodium when it's neutral. If I get rid of that one electron right there, it will follow the octet rule, and that's the ion that forms, right? This is the ion that we always get for sodium. Likewise, for aluminum, barium, or whatever, you're always going to get the same ion. So aluminum always forms this, and you should know why that is by now. Barium always forms this, and you should know why that is by now too. Now, you might be thinking, well, wait a second. If aluminum always follows the octet rule, what about the rest of the stuff in group 3A? Like, shouldn't the things below it all want to ditch 3 electrons? They only have 3 valence electrons, right? And it turns out that they do have 3 valence electrons, but removing 3 electrons would put them somewhere in the middle of the periodic table, right? Because there's all those transition metals in the way. And that makes things kind of weird. Furthermore, the transition metals themselves don't follow the octet rule. They follow their own set of rules. So to lump all of that together, here's what we do. If you are not looking at one of these elements, group 1A, group 2A, or aluminum, so any other metal, then what you need to do is indicate the charge as a Roman numeral. And the way that that works is the following. If I were to give you an ion, oops, I clicked on the wrong thing, I'm sorry. If I were to give you an ion such as chromium with a 3+, and I said, what's the name of this? You would call this chromium by typing out its name, and then putting a parentheses, and writing the Roman numeral 3. Close parentheses. Now you'll notice that there is no space between the name and the charge, or the parentheses, I should say. Okay? That's important. When you are typing this into Canvas to answer it on the quiz, do not enter a space after the word and before the parentheses. Put it all as one contiguous thing, as if it were one word, because it's one name. Secondly, notice that we are not capitalizing. Elements are not proper nouns. They are just elements. They exist. We do not capitalize hydrogen or helium or anything, even though these are elements that are named after all sorts of things, like places or people or even gods. Helios is the god of the sun in Greek mythology, right? I think that's right. Greek or Roman, I don't know. But it's the name of the sun god. That's where the name helium comes from, because helium was first observed in a spectral analysis of the sun. But we don't capitalize it, despite it being named after a deity. We also don't capitalize things like Einsteinium or curium, which are named after Albert Einstein or Marie Curie, respectively. Even though those are very important people, you could say that they're super fundamental to chemistry and physics, especially Marie Curie. She did all sorts of stuff to do with radiation and radioactivity. We still don't capitalize her name. And that's just because that's convention. So no capitalizing element names. The only time that will show up in my slides is if it's at the start of a sentence, or I'm trying to write it as if it's a sentence. So just be mindful of that. We are not going to capitalize anything unless it's the start of a sentence or sentence fragment. Now, you might not know the Roman numerals, and I couldn't criticize you for that, because Roman numerals are used for exactly 3 things. One is Final Fantasy, the other is the Super Bowl, and the third one is naming ionic compounds. So let's write down all the Roman numerals so that you have them available. I gotta resize this so it fits there. Oops, there we go. So we're going to say, so our numbering system is the Arabic numbering system, and it is super awesome because it's base 10. Then we got the Roman numbering system, which is the reason the Roman Empire fell, is because their numbering system was dumb. And so we'll just go, we'll do it like this. 1, 2, 3, 4, 5, 6, 7, 8. All right. And the way that this works is that for Roman, we use letters to represent numbers. So the first letter is I. The second, for 2, we put 2 of those. So you just write I twice, I. And then 3 is I. And then 4 is actually this. And the reason for that is because 5 is V. And the way that the Romans did 4 was they wanted 4 to be equal to 5 minus 1. So you put the 1 in front to represent subtraction. It's really stupid, right? This is why we don't use Roman numerals for anything. So you put the I in front of the V to indicate I'm subtracting I from V. So 5 minus 1 would be 4. That's how we represent it. You're going to see that down here when we get to 10. 10 is X. You could think of this as sort of like a pseudo base 5 sort of thing. So 6 would be VI. 7 would be VII. 8 is VIII. And then 9, same idea. It's 1 before 10, so I'm going to put the 1 before the 10. There you go. So now you should be able to do Roman numerals up to 10. And there are other letters out there, so I think, so 50 is L, 100 is C for century, 500 I think is D, and then 1,000 is M for millennium. And to make a big number, you just tack all the letters together. So a long time ago on TV, they used to write out, like at the very end of their credits, they'd write like copyright MCM IXIV or whatever. They put a bunch of letters strung together, and that was just the date or the year in Roman numerals. So nobody cares about that anymore. But this is still something that's sort of a legacy thing that's carried over to naming ionic compounds. So it's good to know the first 10. If you play Final Fantasy, you know up to the first 16. And if you watch the Super Bowl, we just hit like what, 51, 52? I don't watch football. When I eventually become king of the of America, the first thing I'm gonna do is ban sports because they're all dumb. I'm just waiting for the comments from you guys for that. There are many things wrong with that sentence, and it was on purpose, but... All right, so that's how we name metals. We're going to put the Roman numeral that represents the charge, like shown on the screen here. All right, now how do we name the non-metal? Well, if you take the name off the periodic table and chop part of it off, you'll replace it with "ide." Now, you've probably seen a bunch of these before, but just in case you haven't, we'll go back over here. Let me do this real quick. And we'll get rid of this off the screen here. And so we're going to look at all the common nonmetals. And I'm going to write their names down here. So. And I'm going to grab my periodic table, and I'm just going to name all the ones that are important, just so you have these. And there's not tons of these. So we've got fluoride. Oops. Not fluoride, sorry. I want to give you their actual names real quick. So we'll put the ides in a second. Fluorine, chlorine, bromine, iodine. I'm going to ignore anything that's radioactive because you're just not going to see it very often. We've got oxygen, sulfur, selenium. Tellurium's a metalloid. I'm going to skip it. Nitrogen, phosphorus. And that's really good enough. You could do arsenic if you wanted to, but Not super important. So what we do here is we chop off the end, and we keep what's called the stem. So I'm going to scribble out the parts that we don't use, which is just usually the last few letters. And what we're going to do is we're just going to tack on... Can I undo? No, I guess not. Okay. Let's fix that. We're going to tack on "ide" to the end. So what we have here, what's left over, is the stem on our slide. And so that gives us names like this: fluoride, or chloride, bromide, iod, oxide, and so on and so forth, right? And we'll write them out so that you have them on the slide and you can refer to them. Nitride, phosphide. And there you go. Now, there is a difference between these names. These guys on the left are elements. And because they are elements, they are neutral. These on the right side are ions, which means that they are charged. And we only use the "ide" name for ions. So that means that there is a difference between chlorine and chloride. What is that difference? Well, if I write this with no charge, that's chlorine with an N. But if I write this with a charge, that's chloride with a D. Another example here. Here's O. That's oxygen. O with a charge on it is oxide. Okay? So be careful. Don't just name elements off the periodic table because that's what you do with the metals. You want to make sure that you use the appropriate ion and the appropriate name. So now that you know how to name metals and nonmetals, you just drop their names in the box that we have right here. Keeping in mind that you may need to adjust the name to deal with a charge, whether it's in group 1, group 2, or is aluminum. All right. So there's my example there. So Cl, again, is chlorine, Cl with a minus. And the minus is kind of small. I actually can barely see that on my preview, but note that that is important there. All right, so let's do an example. So you're going to name the metal and just put it in this box. There is a space between the two names. And then you're going to name the nonmetal with "ide," and then write that as your answer. So here you go. I have KBr. What is this called? Type your answer in the chat. All right, so you might have done this by just looking at the elements and going, oh, well, I know it's an ionic compound. And that's fine. So if you aren't sure, break it into its ions, because all ionic compounds have ions involved. So K plus is in the first column. We would just call it potassium. And then Br with a minus is a nonmetal that we change to ide. So instead of writing potassium bromine, we would write for potassium bromide. There you go. And that's the name. Just make sure you don't capitalize it. You'll notice that I capitalized it here because it was the start of a sentence, and Microsoft probably auto-corrected it for me. So just be mindful that you aren't capitalizing things unnecessarily. All right, let's do another one. What is this called? Now, you might be like, oh, what do I do with the 2? And my answer to that question would be, did we say to do anything about the 2? If not, ignore it, right? So don't worry about how many there are. Just follow the rules. I realize I'm a little bit in the future because there's like 30 seconds of lag here. But hopefully you've worked it out. I can see answers popping up in there. That's good. I'm going to split these into their ions. So I've got a sodium and another sodium and an oxide. So even though there's 2 of them, we just write what we see because the rules did not say anything to do with number. Just write what the metal is and what the nonmetal is with ide, right? So I got sodium oxide. There you go. All right. Let's do another type of question. First, I want you to make a formula out of these ions, and then tell me what its name is. You'll notice that I had to change how I'm asking the question for something like this compound with cobalt in it, because it's a transition metal. So, using the information that's present, give me the formula of the ionic compound that you make, and then give me its name in the chat. I'll give you about 2 minutes to do that. Don't forget to include the formula, because we want that too. All right, so let's put these together. So how many of each do I need to complete my ionic compound. So if I put two of these together, will the total charge be 0? And it turns out that if I do this, I end up with 1 plus left over, right? So I need more negative charge to balance this out. So my formula would be, I would just combine all of these together. There's my formula. Now, from the formula, it's kind of difficult to tell what the name is. That's why you need to actually go in reverse to get these ions. Because now you can say, oh, I know what this is in here. This is cobalt 2. And this, or this, they're the same thing, is my chloride. So when you name an ionic compound, you need to know the ions that are in it. So we need to have this information handy. However, not all of the problems will have that information immediately apparent to you. They might just give you something like, oh, okay, here's what you got. Tell me what the ions are and tell me what its name is. And you'd have to say, oh, okay, well, I have to split it into my ions and do what we did before, right? And say, well, if this is 6 minus, then this must be 6 plus. And so now you would know, oh, it's tungsten with a 6 charge on it, or tungsten 6. The amount of nonmetals doesn't matter. That's correct. Yeah. So the number of ions that you have does not matter. There's no part of our little formula right here that we were using. Nothing in this says anything about numbers. So you can ignore the number of ions that there are. You're just going to name the metal what it is and name the nonmetal with "ide." Oops, you can't read any of that. Let me fix that. There we go. I'm going to give you another one. I want you to name this one. Tell me what the formula is and also give me its name. Go ahead and do that. All right, looks like we got the answer, and that is the correct answer. So if I were to put my ions together, do the charges balance out? Yeah, they totally do, right? So my formula would then be MnO PQRSTVWXYZ. No. And what would we name it? Well, this is manganese 2. And then this is oxide. And there you go. Make sure you spell manganese correctly. It has manga in it, like the Japanese comic. That's how I remember it. Be real careful with your spelling. Have the periodic table, have P table open and handy when you're taking this quiz. And just refer to it. Like, yeah, you're going to be typing names off a periodic table. Well, guess what? In real life, you will always have the periodic table next to you, no matter what. We never expect you to memorize the periodic table in chemistry. Some instructors want you to memorize the first few elements, and I think that that's dumb. You'll learn it as you use it. I don't think that memorizing it is worth an exercise we're doing. So, refer to the periodic table and just make sure that you're typing in the name exactly as shown. All right. So I'm going to give you 2 pages of these. So this is page 1, and then there's page 2. I'm going to let you do page 1 for now. We'll go over all the answers together on page 1. And then I'll let you do page 2. We'll go over those answers, and then we'll continue. We'll probably have a little bit of time to do polyatomic ions before the break. Okay? So I want you to take the top element, or I'm sorry, not the top elements, the top ionic compounds, and turn them into a name. Now you're going to need to split them into ions in order to do that. And then at the bottom, I want you to tell me the formula of the compound. So you're going to have to turn the name into ions and then turn that into the formula. We didn't do the bottom part, but it's basically what we did, but backwards. So try it for a little bit, and then we'll go over the answer, and I'll show you how I do it. 5 minutes or so, I think that should be enough. All right, see you in a bit. All right, 2 more minutes and we'll go over the answers to these. All right, let's go over the answers. All right, so we've got, for this first one, if we split it into its ions, we've got 2 lithium ions and an oxide ion. How do we know what ions they make? Remember, we follow the octet rule. And so I would call this lithium oxide. Notice that we did not put the charge in parentheses because these elements are in group 1A, 2A, or sorry, the metals are group 1A, 2A, or aluminum. Also note that when you're naming the Roman numeral for the charge, you only look at the charge on one of them, not the total charge. For the second one here, we've got beryllium, and I've got chlorides here. There you go. The third one here, we've got aluminums and oxides. And then the fourth one here, we've got potassium and iodide. All right, for the next set here, we've got strontium. What ion does strontium form? It forms this. What about bromide? That's that. Now I have to put together the two pieces. How many negative and how many positive do I need? We did that in Unit 9, right? Do I have a total charge of 0? No, I need more negatives, right? So this would be my formula. So be careful. It's very easy to make mistakes on these. We're sort of putting all the steps together that we have used from previous units. This is sort of our capstone, as you would. So is including the charges on elements on groups 1A or 2A considered incorrect? If you include the corrected charge, so like if you said sodium parentheses 1, it's redundant but not technically wrong. However, when you are entering your names on Canvas, if you add extra characters and it's not expecting them, it does mark it wrong. And I've programmed it to only accept the name without the Roman numerals if the Roman numerals are not required. And I believe that the instructions say that. It says use Roman numerals for charges only when absolutely necessary. So don't put it on anything optional. And in fact, that's sort of one of the situations where if you said sodium 1 oxide to someone who was actually a chemist, they would laugh and be, oh, you must be new. And so I call this other scientists would laugh at you. And we don't want that. Other scientists are pricks, and we don't want to give them the benefit of whatever, right? We don't want to give them the joy. Screw those guys. All right, so let's do this for rubidium nitrate. Or nitride, sorry. So here's rubidium, and then here's nitride, and I do the same thing. Are my charges balanced? No, I need more positives. So I add enough of them so that everything balances out. I have 3 positive 1s. I have a negative 3. I then put everything together for my formula. Alright, I have to get clear, unfortunately, to get the last few. So I'm going to delete everything on the slide here. Boop. So for sodium sulfide, we've got sodium and sulfide. How many of what do we need? Don't have enough positive to balance out my negative, right? So if I do that, there we go. There's my formula. And then the last one, here's magnesium, Mg2+. Iodide is I-. Do I have enough of everything? No, I need more of this to balance out the charge. There's your formula. That should be a G. There we go. All right. When we come back from the break, that took a little longer than I expected. When we come back from the break, we'll do these. You can start on them if you want, but oops, that's the wrong card. But obviously, I would prefer that you take a break because you deserve it. I am not of the opinion that I should push people to work through breaks, but some people get bored. So I'm gonna start the timer. I'm gonna go get the music going. I promise not to leave it on mute this time, like I did yesterday. So I'll fix that right now. There we go. Oh, apparently this is the first song again, but at a live performance, so I'm just going to go to the next one. Alright, see you in a bit. Alright, we're back. So go ahead and try these now. So I've thrown transition metals into the mix, so you're going to have a bunch of Roman numerals going on. So your task, once again, is to give me the formula and the name of the top set. And then down at the bottom, what I want you to do is just break those into ions. And if you want, you can make a formula out of them. But the assignment for the bottom set is just tell me what these ions are for these ionic compounds. It says molecules there. It really shouldn't. Let me fix that. Anyway, go ahead and do that while I edit this, because these aren't molecules. Oops, sorry. There we go. Let's do 2 more minutes unless people need more time. I'm kind of trying to go slow, so if we push this into Wednesday's discussion, then I can give you an extra day to do the quizzes so they aren't crammed together. So we're taking our time. Let me know if you need more time. Otherwise, 2 more minutes. All right, let's go over these examples here. So, putting these together, we've been doing this all along, right? Charges don't balance, so I need more. So my formula would be COBr3. And then what would its name be? Well, I've got the 3 charge here, so this would be cobalt 3 bromide. And then this one right here, I need more negatives, so I gotta put these together. So the name of this would be titanium. And then what's its charge? Well, it's 4. And then oxide. Just dropping the names in the box. Easy as that. And then finally, this one down here, we've got chromium with a 2+ and sulfide. Those charges balance, so we could just go CRS. Oh, I didn't do the formula up here. This formula was TiO2. Back down here, we got chromium, parentheses 2, sulfide. Ah! Lost part of my I. The letter I, not my organ. Alright, so that's the top part. You can pause the video if you need to record that or write it down. I'm going to hit clear now. Boop. There it goes. Alright, so now we got gold with a 1 in front of it. So we got to write the symbol for gold, and there's that. We got chloride, which is this. And if you wanted to make a formula out of those, well, the charges do balance, so you could just do this. And there you go. There's gold 1 chloride. And you'll notice that I'm starting to mix them up now, because what you're going to see on the quiz is you're just going to see them all scrambled together. And you'll have to apply the correct rules to the correct things. There's my sodium. There's my nitride. I think we've done this example to death. I don't know, I keep picking Na3N for some reason. There's barium, there's my oxide, here's the formula. And then platinum 4 has a 4 plus charge. Fluoride is F minus. I need 4 fluorides to balance out that 4 plus, so PTF4. There you go. All right. That's how you name ionic compounds, how you split names into ions, into formulas, and so on and so forth. So the last thing that we have to do for naming ionic compounds is we need to learn how to deal with polyatomic ionic compounds. And it turns out that if you see a polyatomic ion in your ionic compound, it's real easy to do the naming. You just take whatever name the ion has and you just replace whatever the box is with the name of the ion. So if I gave you this, you'd say, oh, I have ammonium. I'll just put its name as the metal. Oh, I have chloride. There you go. What if I gave you something like this? I messed up. Hold on. There you go. You don't actually need parentheses for that. Give me just a second. Let's do that. I'll make it more complicated just so we have a better example here. So what ions are present for this? How would I name it? Well, I'm going to need more space. Oh, you know what I could do? I could do that. So let's split this into the ions that are present. So I've got carbonates. And you're going to have to either know or look up what the charge is on each carbonate. And it turns out it's this. And then I've got 2 irons, but I don't know what their charge is. Those are supposed to be question marks. And so you have to solve backwards like you would with other ionic compounds. So I know that I have a total of 6 negative here. Because I got -2, -4, -6. In order for this to be an ionic compound, I have to have the same amount of positive, right? So, what would this 6 positive be split among these 2? It'd be this. So now that I know the name of this, I would say, okay, well, this is iron 3. So name the metal iron 3. And then I just name whatever this is. Carbonate. So now you're doing the exact same thing that you were doing before. However, you do have to have your polyatomic ions list handy or memorized in order to answer the questions. Okay? So let's get some more practice here. What would you name this? If you don't have the polyatomic ions memorized, which assuredly you probably don't, go to the Unit 6 slides and look them up. So tell me what you would name this in the chat. We all know what the potassium is, but what's the MnO4 thing? What is that? Alright, so hopefully you've looked up that MnO4 is permanganate. I don't need to write that because I'm going to hit... Oops, I'm on the wrong screen here. I'm just going to hit the button and it's going to appear. But what we can do is we can say, well, here's the potassium part. So that's this. And then this is the permanganate part. Alright, how about this one? This one has two possible names based on which of the names for the polyatomic ion you use. Both are acceptable. I have programmed Canvas to use both of them. So anything that has two names for an ion, you can use either name. So I'll give you a minute or two to write that in the chat. Isn't HSO3 supposed to be HSO4? There should be both. Both of them should be on your list. Oh, look at that. It's not actually... Both of them are not actually on your list. And they don't have both names. Which is strange. Well, you know what? We fix that. I don't want to give you an example that's not on your list, so we'll just do this. Boop. Uh-oh. That's not the intended behavior. Hold on. There we go. It's not liking me editing things. There we go. So I'm going to change it. I changed the 3 to a 4. So that now it is something that is on your list. I thought the other thing was on your list. Oops. I apologize. Because SO3 is definitely on there. That's supposed to be sulfite. Good to know. Thank you for pointing that out. I had no idea. Alright, so now that you found the ion, what would you call this? Well, you just say sodium and then the name of the polyatomic ion, which would just be bisulfate. So there you go. Alright. So what I want you to do... I have a bunch of these, I guess. Oops. I'm all mixed up here. So what I want you to do is, at the top, I want you to name those ionic compounds. You are going to have to refer to your list. And then down at the bottom, I want you to turn the name into a formula. And then the second set of exercises, which is over here, just involves transition metals. So do these 7 examples for now. We'll go over the answers in about 5 or 6 minutes. Type your answers in the chat to the best of your ability. And I'll see you in a bit. 2 or 3 more minutes or so. Make sure to type your answers in the chat once you got them. All right. So, let's go over these answers. Excuse me. So, for this first one, we've got ammonium and sulfate here. So, we're just going to write those names. I don't know why I put an H in there. Boop. I was writing the or something. This right here, ClO3 with a minus charge on it, is chlorate. So this is potassium chlorate. This is carbonate. So we've got barium carbonate. And then this is dichromate. So we have lithium dichromate. And then just so you see the ions, I'm going to write what the ions are. So we've got NH4 plus and SO4 2 minus. I'm not going to balance the charges because you could do that if you want. Oops. Don't know where that went. We got barium and carbonate. And then finally lithium and dichromate. There you go. So there's those charges. All right, let's do these down here. Write the formula. So first we got sodium, so that's just this. We got hydrogen carbonate, so that's this, according to your polyatomic ions list. So one positive, one negative, so we can just combine those. Believe it or not, that is baking soda right there. NaHCO3. That is probably in your cabinet. Either you use it for cooking or you use it to de-stink stuff. I used to use it for the cat box. Now I just have like one of those little Glade plug-in things. Cats are wonderful, but cat boxes are not. Here we got ammonium. That's NH4 with a plus. Nitrite is NO2 with a minus. One positive, one negative, so I could just put them together. NH4, NO2. Be real careful about this. So if you accidentally say nitrate, which is NO3, nitrite is NO2. Very subtle difference, so just be mindful of that. And then finally, oh, is hydrogen carbonate the same as bicarbonate? Is that another one where the slides don't... Did I remove half the names or something here? Yeah, I gave you bicarbonate. Bicarbonate and hydrogen carbonate are the same thing. Wow, I didn't realize that. I'm going to have to go back and edit these slides. That's strange, because I swear that I copied it from my other slide list. But yeah, hydrogen carbonate is the same as bicarbonate, so let's write that down here. So I can see if you have difficulty finding that one. All right, and then finally potassium and phosphate. I need 3 of the potassiums to balance out the charge on the phosphate, and so we get this. So make sure you balance out the charges and write the formula. All of our ionic compounds should have a total charge of 0. All right, I'm going to give you the last set, which involves some transition metals that have Roman numerals in here. So go ahead and play around with these for about 5 minutes or so. We'll go over the answers in a second. And then we'll probably be done, I think. So I'll see you in a bit. All right, 1 or 2 more minutes. We'll go over the answers. All right, let's go over the answers here. Where did the stylus go? I just had it. Oh, there it is, right there. All right, so we've got calcium. I'll just write down here. And then sulfate. Those charges balance out, so we just put them together. So there's calcium sulfate. What about rubidium and hydroxide? So these are pretty straightforward examples because I'm giving you charges that match up. Then I start to give you a little more mixed bag here. So we got nickel 2, so that's Ni with a 2+. And then cyanide is this. I need 2 of these to balance out with the 2+, so I would have Ni, parentheses, Cn, 2. Sorry, I hear Maya meowing, and I'm just like, ugh. She's in the hallway meowing at me. Probably wants dinner. All right, and then molybdenum, 6+. Phosphate is this, PO4 with a 3-. I need 2 of these to balance out the 6+, so then the result that I get is MO, PO4, 2. All right. So today was difficult, not because of the naming part, but like, how do I get these ionic compounds? I would recommend to review Unit 9 and do as many examples from that as you can, particularly the end where we're making ionic compounds. Because that's what we're doing here, is we're basically reviewing Unit 9. And once you know how to do that real well, then we can start naming stuff effectively. Okay? I think that's all we're going to have time for today, because I'm not going to do the next part in 10 minutes. This is just more practice for you to try. So I'm going to leave these exercises for you to do. But I will write down the answers real quick. So the first one here is that. So here are the answers if you need them. There you go. There's the answers to those 4. Go ahead and try those on your own, though, before going straight to the answers. And then when we come back tomorrow, we're going to do the last 2 sections, because molecular compound naming and acid naming is not as complicated. We'll just do that, and then we'll have a review. That way we'll actually use up the entire period, and we'll stay on the schedule that I have in the syllabus. So, a little more lecture just to catch up tomorrow. All right. I do want to thank everyone for coming out to the lecture. Make sure that you are staying on top of the quizzes. They won't be as crammed together as I thought, because we'll have an extra day between Quiz 5 and Quiz 6 being due. So that's good. Otherwise, do get lab number 3 in. It is due tomorrow. And then quiz number 5 is next week. Yeah, I think that's all I have. Have a wonderful evening, and we'll see you tomorrow for the review and the rest of Unit 11. Take care.